Hey guys, and welcome back to the dashboard series. So in the last video we managed to get our loss ratio graph finished. We got the functionality from this drop down and this range slider built into our graph, so we can obviously move it around and get the details out of it that we require. What that leaves us to do now in this video is to complete these two graphs. So this will be a claim severity graph and this will be the sum insured distribution graph. So let's take a look at that now. So we'll start with the claim severity graph. So we'll go app.callback and we'll have an output. So we'll send it to that severity graph that I just showed you on the dashboard, and since it's a graph we have a string of figure passed in there, and then our input will be severity dist years and the value. And just to quickly show that, it will be that the years from this drop down will feed into this graph and the years from this drop down will feed into the sum insured graph. So now we'll write our function here. So we have def and we go make severity distribution, or dist, sorry, go severity dist years. So we pass that through. It's just a one parameter, one input. In this instance there's no range slider like the loss ratio video, but we will have to do a bit of manipulation to our data. So we'll create this DFF variable again and have inception year dot is in severity dist years, so filtering our data. And then we'll have this line here as well. We'll have DFF and then we go DFF such that DFF incur or claim incurred is greater than 0. Oops. And the reason we do that is because, I don't know if you looked at the data at the start, but if you went into the actual data set, the claim incurred column will have a bunch of zeros in there. And the reason is because you can think of the data as a bunch of policies that different people have, and not everybody's going to have a claim. So the majority of the values in the claim incurred column for each row, it's going to be 0, but then for whatever frequency the claims happen, there will be a value in the claim incurred column that's a non-zero value. But because we're going to plot this on the graph as a histogram, we don't want to plot the 0 values because there's going to be such a huge count, because it's going to take up the majority of that column, and there's just going to be a huge tower that fills up the first bin, a huge count that fills up the first bin, making that big tower, and it's just going to look a bit silly on our graph. So that's why we're filtering the data frame here so that the claim incurred is greater than 0. We only want to plot the actual where claims happen so we can see the distribution of the claims, not where there hasn't been one. Now we'll create our fig. We'll go fig, we go px, and this time we go histogram. Whoops. Histogram, and go DFF, which was our data, x equals claim incurred, which is the column in the data frame I was just referring to. On our marginal axis, we'll have a violin plot, and for the number of bins we'll have 10,000. And we'll quickly do this as well. We'll go fig.update layout, go title text, we'll call our graph, we'll go incurred claims distribution. For x-axis title text, we'll just call that claim amount, and for the y-axis title text we'll just call that count, and then down here we'll go return fig. So if we hit save there, what we can see here is we can see our title here, so our incurred claims distribution Up the top here is our violin. So what it does is, if you haven't seen one of these before, it sort of goes out here where the distribution is more densely populated, so it's heavily distributed around this region, so it shows that through there. And then out here you see these dots, these are like the outliers as it goes way out into the claims tail. So if you wanted just to focus in here, what we can do is we can just highlight that area. We get a better view of our distribution. There's the violin pod, it's changed with it. And as I think I said in the tour at the very first intro video, that you'll typically see this sort of shape in a insurance claims distribution, because you're going to have a lot of littler claims, but then you will have claims that go way out into the tail. And for the year that we've got here, 2019, it looks like the biggest claim was way out here, which is 200,000, and depending on the value of the property itself, that could have been close to a total loss if the house was only worth, say, 200, around that 200,000 mark. So, but a lot of these claims around here are going to be more common at a smaller value. So we'll have a look now at our sum insured graph. So this one's really similar. So we go app.callback, output, sum insured graph there, figure in there. Our input's going to be sum insured years, which is coming from that drop down user selected in the dashboard itself. The value, we go def, we go make sum insured graph, and we pass in the sum insured years that again the user selects in the dashboard itself. Now we create another DFF variable and we go df such that df inception years, or inception year I should say, then we go dot is in, and then we go sum insured years. Now we don't need this line here, the one that I was talking about, how we filtered the data frame again so we had the claim incurred greater than 0. We don't need to do that for the sum insured, because you're probably not going to have insurance if you don't have a sum insured there, because you got no value to insure it, particularly for a residential property portfolio. So we can pretty safely assume that the sum insured for each property is going to be greater than 0 already. So now we go fig, we go px.histogram again, taking this DFF X, this time we want to pick up sum insured column, marginal, we'll go a violin again, and end bins 10,000 again, and then fig dot update layout. So we want a title, so a title text, call that sum insured distribution, x-axis title text, we'll call that sum insured, and y-axis title text, call that count. And lastly, we need to return our figure again, so we go return fig, save our code, and hopefully it's all worked, because if it has, it means we've finished. There you have it. So there's a sum insured distribution. It looks a lot like your claims distribution in terms of the actual dash layout. The distribution itself, in terms of the data, looks pretty similar as well. It looks a bit different. It looks a little bit smoother, I'd say. But it's similar sort of concept. Like most of your home values are going to be clustered around this sort of lower end of the distribution, whereas you've got a couple of people out here that one guy's got a $4.3 million property and this one's 3.2 and whatever. So there's a few high value properties way out in the tail, but most of your sum insureds are clustered around this lower end where you just got your average suburban sort of house. So there it is. We've built the dashboard in its entirety. I think it's pretty, not so much, you may not get too much use out of this specifically. It's still pretty basic, but I think it gives you a really good introduction to what Dash is capable of, and you can make these way more complex than what I've done here. I just wanted to keep this one simple for a sort of introductory one, so you could get an idea of what's possible here. But I hope the series and this video itself were helpful. If you want to support the channel, I'd appreciate it if you subscribe to the channel, and I'll try to put up more content as we move forward. Maybe a couple more dashboards where we get into something a bit more complicated than what we've got here.